in May, we're going to have a kind of follow-up presentation on modular construction, do kind of a panel discussion on that topic as well. I see Mark's joining us. Mark's works for M.A. Mortensen. They've got a modular division now that they've had for about 3 different years here. So Pete, if you want to share your screen, I'm going to mute and get out of the way. Welcome. Okay. Glad you're here with us. Take it away.
Well, thank you. Okay, so give me 1 minute and I'll share that. If you could just, whoever's in charge, just give me the ability to share.
Jordan, are you listening?
Yeah, I think you should have it.
Now. Okay, can you see my screen okay? Should just say cold form steel framing.
Yep, looks great.
Perfect. Okay, yes, so thanks for having me. I'm excited to be just part of the education series. Anything I can do to just help move construction, towards less frustration and more innovation, I'm all for that. So that's what I'm all about. So who I am, if I can get my clicker to work here. So I'll just cover a little bit who, so I'm president, owner of Walltech and Wall Panel Prefab. Wall Panel Prefab is our prefabrication company. We do work throughout the country, primarily in the Midwest, but we've done several jobs, from coast to coast. So for the right project, whether we're teaming up with an install partner, a general contractor that does the install, or we do the install. So we do some of all that. So what we do is engineer, prefabricate, and install cold form framing, and our goal is to just provide that that construction certainty, the schedule certainty on the project. So our goal is to do the work in half the time as traditional construction. So I'm not going to read this. I think I've heard that most people have seen the course credits and the requirements for that. So that's okay. I'll skip past that. Course description, again, just talking about prefab, cold form framing and prefab and what the benefits are. Talk about so I'll just cover this quickly. Just this is the agenda. Talk about prefab versus traditional construction. Talk about basic detailing techniques, and then we'll touch on the mid-rise multifamily construction a little bit, and then go through some examples, and then really just boil that down into 5 simple steps to execute on. Okay, so the big picture, I wanted to cover this slide. It's a really good representation. Dodge Analytics did a great job last summer. They put together a survey, and the top line there represents, again, the frustration that the owners are feeling. 49% of the owners were over budget, 61 were completed behind schedule, which is why it drove Dodge into this survey. So 48% of the general contractors and construction managers are seeing that the budget decreased by more than 10%. And when you factor in that next line, that 20% yellow, that's basically 68% have see more than 6% savings on their projects. And then the next bar there is the schedule performance. 40% of the GCs and CMs again are seeing at least a 10% savings in schedule. And you factor in that next group, 60% of at least 6% savings on schedule. So pretty significant. These up here, the 90% are reporting improved quality, 80% increased customer client satisfaction, and then not surprising is 79% are reporting improved safety, which is many times people aren't considering the safety impact of how prefabrication can help with the safety, overall safety of the project. So again, I think what I'd like to do is, again, we're going to be concentrated on the cold form framing. So how do we take the benefits that we just talked about on that survey and apply it to cold form framing and a little bit on the drywall side? So, so again, with the frustration that our customers are feeling, one of the examples I'd like to share with, I had the frustration of driving past a job a block away from our office. Most of last summer, it was about a 3-month enclosure. So if we look at just the cold form framing enclosure, it was 3 months, but unfortunately it turned into a 4-month enclosure. And when we look at that, when the reason I say that that's such a frustration, because as an industry, I'm frustrated when I drive by the slow pace of these jobs. And for example, that job, it was a 3-story office building. It's probably about 40, 50,000 square feet, not a huge building. But to take 3 months to enclose the exterior of the building is pretty pathetic. And just because people aren't aware of what you can do with prefabrication and speeding up the enclosures. And so that job, it actually turned into a 4-month schedule because about, half of the way through, the contractor on site, I don't know if they didn't have manpower, they ran out of materials or what it was, but it just sat there and nothing happened on the exterior skin for about a month, which meant that the roofing couldn't start, the brick couldn't start, the metal panel couldn't start, so the windows couldn't go in. So everything else progressed down further on the schedule and just held up the job. So I can just imagine the frustration both on the owner side and the general contractor side, seeing his building sit there not being finished. So that's what my focus is, share with you some of those things that no matter who's doing it for you, should be able to benefit from whoever the contractor is. So again, traditional framing, expensive, can't not all the time, but quality can be inconsistent, stressful with workforces and weather and everything else. So a couple of the key components that we look at from my perspective is on the cold form framing side, drywall package. The exterior walls is of course the most common, the enclosures, the exterior, just getting the building enclosed. Structural load bearing framing, we'll touch on that a little bit more. Roof trusses and floor systems, there's a lot of prefabrication that can be done and even more. Interior non-structural framing. And then there's a lot of opportunities on components. It doesn't need to be huge panels that you need a crane to set. There's a lot of opportunities just on building components, small components that can speed up the project and have less people on site. Bathrooms, I want to touch on that a little bit. I got a couple slides on that. Bathroom pods are great. There's a lot of movement on bathroom pods. And then drywall, there's less on that, but with CNC machining, there's some opportunities on prefabricating drywall shapes and speeding up some of that. And then even opportunities to pull in mechanical, electrical, and plumbing rough-ins. So when you ask, okay, what projects can lend themselves to prefabrication? It's pretty much, my opinion, every job can benefit from, now again, I'm biased a little bit, but if you're geared up and set up, there shouldn't be any project that really shouldn't or couldn't benefit from prefabrication. But these are the most common ones. And also there's a lot of work in those categories: healthcare, hotels, apartments, schools, et cetera. So cover the quick bullet points of the benefits. Again, quality, certainty, reduce waste on site, better customer service or satisfaction, safety performance. I want to cover a couple of these pictures here. Again, since my advice when I started this is don't read the screen, the PowerPoint. Down in the lower right-hand side there, that's kind of an interesting job. We've done, it was about 5 penthouse units. We teamed up with the mechanical contractor. We built those mechanical units. They went on a school. So what we did is we prefabricated that whole unit. It kind of looks like a garage, but the cladding went on, the finished cladding, the roofing system. Then we had all the structural steel so they could pick that whole thing as a unit. So we shipped it to the manufacturer, the HVAC contractor's manufacturing site, and they actually installed all their equipment. And then when this got picked up on the roof, basically all they had to do is attach the ductwork to underside. So we did all that while the building's getting erected, the schools were getting erected. And when they set that, again, on site, all they had to do is hook up the ductwork and all the equipment was tested and installed with controls and everything. So it was pretty good success story there. And of course, the obvious thing right now with COVID, with just social distancing, manpower restrictions on site, and the thing that still gets missed is there's a shortage of manpower in general construction, and it helps. You can do work on site construction with 5 people where you might have 30 people stick framing it. A couple examples again was how can you really leverage prefabrication? So it's not just taking prefabrication and taking it at the basic component, but really amping that up with adding air and vapor barriers, window blocking, temporary enclosures, brick angles, brick relief angles. Again, just a picture there of small components. There's opportunities, not just prefabricating roof trusses, but now taking that to the next step and doing big gang shapes and lifting up whole sections of roof or floor systems. We've had pretty good success with continuous installation with even the brick ties, like down in the lower right here. So one thing, again, a lot of people know, they're familiar with the bathroom pods. And I think as an industry, there's people on 2 extremes, people that are all gung-ho about prefabrication, and the industry might not be ready for that, and then traditional framing. So that's the same thing with bathroom pods. It's a great product. It can be pre-finished with the tile fixtures and everything in it, but that's not our business. And I know there's a lot of great companies that do that work, but there's that middle ground is what else can we do as an industry? That's the biggest bottleneck on some of these projects, getting the bathrooms done in any condo or apartment with a lot of repeat hospitals. Same thing, is a lot of repeat units like bathrooms. And so we can incorporate all the coordination with the plumbing fixtures, electrical fixtures, grab bars, and incorporate that into small panels, lightweight panels that can be basically on pallets. They're pretty lightweight. They get, you can move them around at the pallet jack in the building, and you basically just tip them up into place. It goes pretty fast, but you just need that design time, that coordination time, get everything early on the schedule, not wait for the last minute. So just a quick video of a job over on the East Coast that we did. One elevation, about 4 hours worth of work. Again, pretty quick. That's the way it should go. Everything's done, coordinated ahead of time. Great general contractor, everything was ready for us. We incorporated continuous installation, the vapor barrier, brick lintels, brick ties. Even on this one, they had brick ties on that as well. HSS steel was incorporated in there, and it goes up. It really goes up that fast. So I didn't mean to show that again, but it's such a great video. Why not, right? Okay, just kidding. Okay, so basic detailing. Let's cover a couple basic detailing. So when we look at the basic detailing, I think when we let's stay away from the load bearing side right now and just talk about the most common is what can we do to speed up construction on your most average job. The typical job is on the enclosure, whether it's an office building or retail building or hospital. We can speed up the enclosure of the building, and it starts with that slab edge. So let me just cover a couple details there. Because if you do it early and you get involved early before the design is 100% done, we can really leverage the techniques and how fast the job can go on site. So the detail on the left is a post-tension concrete job, very common. We're going floor to floor. So we're going to the bottom side of that structure, and then we start the next floor with the exterior framing again from the bottom side, or the structure to the bottom side of the upper floor. So with the most common detailing now with the continuous air and vapor barrier on the outside, we got to run that sheathing path, and you got the continuous insulation. So if you look at that detail, this is a pretty critical detail right here. I don't know if you can see my mouse. And then the one in the middle, the other picture is a traditional bypass where you have again, most typically you'd use that on structural steel, but you could actually use that in other instances as well. And the consideration is you got to look at what's the impact on the slab edge Yes, you have to put slab edge fire safing in there, a smoke barrier, but it shouldn't cost more to do that. You should still save tremendous amount of time, better quality details from the air and vapor barrier standpoint. And whether you prefabbed or not, I think you get a better quality enclosure because you're not stopping and starting at that point, and you got a potential crack line, future crack line. So again, the things to consider there that we see is you got to look at basic construction and if you can incorporate a bypass, and then how do you get the fire stopping in there. You got to have access to these clips, and I'll cover the clips in a little bit more detail. You need access to those clips. And then you want to look at where's the column and wind bracing. Are they in line with the beam in this point, or are you putting them in line with the stud, which really, it's really tough to prefab if you're putting your column and wind bracing within the plane of the wall. It gets very clumsy, and you got a stick frame in between that. And then of course, there's more opportunities we can do with cold form framing with strap bracing and sheathing as well. So when you look at the clips, again, I want to spend a little bit of time on this. The clips are very critical. I think most of you are probably aware of the clips, bypass clips, just for, this is probably the most common, the one on the left-hand side. But the thing to keep in mind, if you look at the one on the left-hand side, you need access to that. And yes, some people ask, well, why can't you just install that from the top side on the inside? One, it's tough. You can't really get in there to anchor. You don't have enough room most of the time. You can weld it, but now you got a blind weld. I don't like the quality control when you have a blind weld. So then you have leave off panels like the picture in the second one from the right with the green sheathing on. You're leaving off that sheathing so you can get to it. No big deal. Hey, do it all the time. But now if you can imagine, you got continuous insulation or air and vapor barrier. Now you have one more thing you got to come back afterwards and seam up those joints. Again, not a big deal. But now if we could instead move that clip to the bottom of the beam, or the bottom of the slab, now you got rotational forces you got to deal with. So early planning with the structural engineer, a lot of people don't like that because you got to beef up the beam. But again, you got to, what's the driver? You got to, just like any project, you got to weigh the pros and cons. But beefing up the beam, you could put gusset plates in. Occasionally we'll put additional clips or kickers for the cold form framing, and we'll clip to help with the rotation of the beam. And we'll clip that back or brace that back to the structure. But you got to take into the consideration of that rotation of that beam, of course, or just come back in and fill it in afterwards and install your more traditional clip. And there's a couple other options, but those are the most common. Again, it's just the picture on the right is just the guys are up there on top, they're clipping it back, and it kind of just shows you how that whole system kind of comes together. Other architectural considerations is on the window, of course, you have continuous brick relief angles. Can you use loose lintels? Obviously, loose lintels are preferred if you don't have the knife plates and you have to worry about getting back into the structure with a knife plate of some kind, and then now you have a penetration out of every one of you have knife plates, so you got to do your air and vapor barrier, you got to seal that, and we've done that in the factory. But then also with the wood blocking, extending the wood blocking past the window, it's very common. We do it all the time, but it takes a little bit extra effort on the shipping. Obviously, if we had a little bit less trucking, it's a little bit easier to stack these if we didn't have the blocking, but happens all the time, not a big deal. But the nice thing is you could factory apply all the window flashing in the factory if you incorporate the continuous insulation or the continuous air and vapor barrier. And of course, if you do the air barrier, you really want to incorporate that blocking in that system as well. Because otherwise you get, like in this instance, if you're only doing the air and vapor barrier, you can't really seal the window properly, which you're not taking advantage of the quality control and working under controlled environment and the speed. So the other thing you can do is we like incorporating a lot of steel in our walls. So it's a very efficient. We like the HSS members. We can do it headers like on the one on the right. instead of a built-up box beam, it's a little bit it's a very efficient way to transfer those loads. And then same thing with the columns. We can incorporate post HSS members again into that fairly simply. Just a couple pictures on the lower picture here. Is you can see that all the wood blocking is on, the window flashings are done. It's all in its factory setting. And so the different types, I think most people are probably most familiar with the spray applied. We don't like spray applied in the prefab, at least for our operation, because it kind of holds up the operation. You got to wait for it to dry, and it kind of screws things up for stacking and shipping. So we use a lot of peel and stick. There's also a lot of really good products, the pre-applied, factory applied sheathing, whether you got gypsum applied, sheathing products or factory applied air and vapor barrier. Same thing with the plywood or magnesium oxide board. They all have products that are factory applied. The same thing. Then you'd have liquid flashing or rubber flashings to get the windows. But you can see in this picture on the right, as the panels are set, you're ready to go. You can start putting sheathing or the cladding systems on. You can start getting the windows on right away. But you do have to treat the seams, of course. So you can see, I don't know if you can see this in the picture, but in between each window, that's a panel. So we would just treat that seam with, we would usually use, if it's in the winter, in the cold climates like Minnesota or Wisconsin, we'd have the 6-inch rubber bitumen, in a hot box. It's all heated, and then we can just apply that under, I think it's down to 10 degrees below zero with this product. Continuous insulation is surprised that we don't see that more, and I think it's mostly because people aren't aware of the opportunities they can incorporate. So again, MgO or magnesium oxide board, there's a couple good products with the nail base with different thicknesses of insulation. They also have the AVB, either factory applied or a peel and stick product over that. Same thing with the plywood nail base. And then also just this picture here is just in this silver, that's just a foil faced continuous insulation. And that also acts as the air and vapor barrier. Again, all the windows are pre-treated in the factory and shipped to the site. So let's just touch a little bit on mid-rise multi-family construction apartment buildings. I don't know if we want to take a break. Does anyone have any questions so far? Is this a good time to break or just wait until the end? I'm good either way.
I have a question for the group they can think about. So can anyone name the largest project in the Twin Cities that was built with this type of construction? Don't have to answer it now, but think about that later.
We've had two questions come in the chat if you want. Otherwise, we can wait for them. It's up to you.
Sure. You want to?
Sure. So we had one. Gerhard asks, when do you typically come on board to accommodate adjustments to structural elements for allowing unique erection requirements?
Yeah, a lot of times, and I think most fabricators do this as well. And we work with a lot of install partners. So whether you have an install partner that you're working with, we can work with them on the design side. But we like getting involved early before someone spends, $50,000 or $100,000 on design fees, and then they pivot and want to change. It's very hard to make some of those changes. So the earlier the better. We worked off a napkin sketches. Hey, this is what we want to do, and we can give some feedback on that construction. And basically that's where I spend all my time, is on the design build side and just doing that consulting side on the front end. I mean, it's free consulting, but.
So Pete, this is Gerhard asking that question. Are you engaged through the CM or the GC, or are you invited by the design entity? How does that usually work?
Yeah, normally I would get involved either like I say, a general or developer is interested in prefabrication, I'll get involved and just give them some budget up front. But I prefer to work with like the general contractor would typically be the one. Part of that in prefabrication in general, with any prefabrication, and ours is no different, is you want to have a team that's proactive and they're already in sync. They're not going to be fighting the planning and the coordination that you need. So I like that the general contractors get involved and start planning early and to take that into consideration. But we'll work with the architects, engineers on the front end as well. If that's as far as the job is, I don't have a problem with that, and I don't think most people do either. That my peers. But we have turned down jobs because you could tell the customer, it just isn't. They're more. It's going to be a struggle for the entire project, and it's just, hey, one thing we have learned from past lessons. This isn't our first rodeo, and when you run up to someone that's going to buck the system all the way along, it's just a very frustrating process for everybody. So we tend to stay away from those projects.
Hey, Pete, can you hear me?
Yes. Yep.
Okay, my name is Joyce Burney. I have a couple of questions. One about the bathrooms. I didn't see any fixtures in there. Are they added later?
Yeah, so if you did a bathroom pod, again, we don't do bathroom pods, but a very good product, the bathroom pods. There are some fabricators that do bathroom pods, and they do install all the fixtures. The one that I showed in my example was the product that we would provide would be more components. We would do all the planning, coordinate everything on the wall that goes into that bathroom, and then we would do those individually and tip them up into place. And then in that case, there's no fixtures applied to that. You still have to do drywall and tape and finish before you could apply the fixtures.
I was asking because I was wondering how you were going to connect the toilet. Is it, if it can't be set because you got to have the drainage connection.
Yep, exactly.
So the second question is, I was looking at your photo of the wall being constructed in the foil on top of the insulation. How do you make that continuous? Do you leave the sticky back on the foil edges and overlap them, or how do you make that continuous?
No, we would put as part of the system is they have a flashing that would go over that, and some manufacturers require you caulk that, others do not because they have it tested. So it's usually not required that it's part of that same skin that you apply it afterwards. So the key is you want to keep the dust down. You don't want to have all the walls up and collecting dust as they're doing earthwork and site work. You want to get that done right away so you're not collecting that dust. Otherwise, you might have to prime the surface before you put that flashing on.
Pete, can I jump in again?
Sure.
So again, we try to make this as generic as possible, but if you were to ask where's a local project where bathrooms were flown in, built off-site and brought in, the Sanford Health Hospital in West Fargo was done that way years ago with M.A. Mortensen. And I know, again, through their modular system with Blue Vera, they do some things like you're talking about, where put fixtures and everything. It's all ceramic tile, everything's inside the unit. So.
And I think building inspectors are getting more on board with approving that without having to see the rough-ins within the wall. Initially, that was the biggest struggle with the different building inspectors throughout the country not accepting that if they can't see what was completed inside that wall.
So Paul was asking, how do you incorporate fireproofing around those structural steel tubes that you put in for lintels and such?
We've never had to do any fireproofing for that, as long as if it's in within a fire-rated assembly. It's part of that assembly, and actually the tube association has technical data that would back that up, that that's actually a cold form shape, that it doesn't actually require fireproofing even in a fire rated assembly.
And Gerhard was asking about how do we address NFPA 285. We talked about that as a chapter last fall. We're probably going to go back and address NFPA 285 at a future meeting. But it's a big topic. You want to just give a brief answer there?
So is that with the continuous installation on the exterior and the fire rating?
Yes, because NFPA 285, we worry about the air water vapor retarder, the cladding system, the insulation.
Yeah, I think it's just
all those
from
things.
my perspective. I'm not an expert on that, but we have good material suppliers that we work with, that we just make sure that we have the right product specified, and we have several different products, different manufacturers that we work with that meet those requirements. And then we also, for the installation in the factory, our guys are trained and inspected. So it's on the quality and the installation side, we don't run into any issues with that.
To follow up on that too, Pete, Gerhard again, is it necessary for you to reach out with an engineering judgment? And if so, are you getting pushback from the AHJs? Because some jurisdictions don't even accept it.
Well, I haven't run into that problem before. We've done plenty of engineering judgments and haven't had any issues.
Okay. And then actually one that I sent directly to you early on, I was curious about how accommodating are the AHJs with the process and or meeting you at the fabrication site to inspect assemblies prior to shipment to the job site. And I got a tail end of that. You had kind of suggested or commented about something like that, where you're saying they're okay with things getting concealed. But are you not still required to have some inspections in the factory, or do you have pre-authorized processes in line that you could sign off on some of these things without them actually being there?
Yeah, we don't do that type of work, so we don't do anything that's enclosed currently. So we've never had a problem with that. It's similar to on-site construction. They can look at everything we build on site. So and we don't do bathroom pods, so I'm not sure how those manufacturers do that.
Okay, you're not actually doing the bathroom pods themselves.
No.
All right, got it.
But I do know that, like, we're doing some work out in California, and there's special requirements that they would like to see on some of that work, and they're okay with photos and on-site inspectors, and then we'd have them in those instances do inspections in our factory and sign off on some random testing.
And how have they been with those situations? Are they pretty accommodating to come to the factory? I assume there's some benefits to that, because you don't have to crawl around things. You get to see it like right up and close and personal, more or less.
With COVID, there a lot of inspectors have gotten very much more comfortable doing remote inspections with video and photos. That we've actually never had an inspector come to our factory. We've had third-party inspectors come through, but especially when you're doing work over in the West Coast, it's not the easiest for someone to come out. But they've been pretty accommodating with just understanding the quality and the photos and the documentations, and a third-party approved third-party inspector.
Okay, thank you.
We've got more questions if you don't mind. And keep the questions coming. We love the interaction.
Sure.
So Ryan's asking, well, maybe get your next slide, but that's okay.
Okay.
Better people come away with their questions answered. So
that's right.
Ryan's asking, have you done any thermal modeling after the panel layout has been determined to confirm compliance of the exterior wall assembly with the code requirements?
We have not. No, we haven't done any of that. Again, you'd think that would happen more often with continuous installation. It's most of the time we run into on most of these projects, people are barely thinking about prefabrication. So to get contractors to look at even prefab exterior wall can be a stretch, let alone adding continuous installation on the projects as well.
And then James is asking what some of your quality assurance challenges with just making it offsite, shipping it, getting it there, handling the panels, not damaging them. How's that work?
Yeah, when do we cover? I have some good slides that I can cover just to touch about, again, best practices for getting the field, basically like getting it from factory to field. So I can cover that in a little bit easier.
Okay, we'll let you keep going.
Okay. So I have a short video. I think it might be the next slide here. Just again, a little bit on mid-rise, multifamily, mid-rise construction. And we do a lot of that. It's on the rise, especially with wood prices going up so much, like 250, 300% on wood pricing. And I'll touch on some of the benefits of that, but just show you a little video here first to start with. Okay, I didn't have it in the same order, but again, speed of installation. Steel has the highest strength to weight ratio. I won't cover all of these, but it's got a lot of benefits, especially when you compare it over wood, and then when you compare it to concrete or steel, it can be much less expensive. So this is a very common apartment building and multifamily project. The walls will be prefabricated. In this case, the floors were prefabricated. You'll see in some of these walls that start dropping into place, the X strapping. So that's the shear, getting that lateral force out. Most of the jobs have the stair and elevator shafts with reinforced concrete or reinforced masonry. And that's where a lot of that shear is coming out, but we still have the shear design in our system, our cold form framing as well. And the floor system is left off of this video just for clarity, but there's many different options for floor systems that I can cover if we have time. It goes pretty quick. You can see that typically we would do a level like that every 2 weeks or so. So it goes pretty fast. So speed, you got the predictability. We're utilizing BIM, incorporating all that coordination side, and then it's again compared to concrete, it's cheaper. With wood, it's actually in some cases it's cheaper. In most cases, right now, it's about the same cost as wood. But before the increase, it was a little bit more than a couple dollars per square foot more than wood, but it's got some other benefits. So the benefits when you compare it to the wood, and the reason I bring this up, because a lot of people I ask about how does it really how is it really different than wood? But the biggest thing is that first bullet point there, the wood compresses, especially with new growth timbers. Most people don't talk about the new growth timbers that have really hit the market in the last several years. It shrinks a lot and it compresses more. So studies have said that you got about 3/8 of an inch per floor. Again, it's load bearing, so you got the weight of the upper floors compressing that product, and that's where you have a lot of shrinkage and warping going on site. And then when you look at SFIA, which is the Steel Framing Industry Association, the savings on insurance most of the time gets overlooked. Most people don't know of it, about the benefits, but when you look at the builder's risk, general liability, and excess liability insurance, the insurance premiums represent 5% during construction and 10% of the long-term operation of the project. And when you have a non-combustible project, that can factor in most cases, it's going to factor in some savings to the owner of the facility. It's just again, it doesn't get factored in because people aren't zeroed in on that. And there's a good study on the SFIA website you can download. Some of the bigger jobs, it's well over $1 million in savings over 5 years. So if you go on their website, you can download it, or you can give me a call or send me a note, and I can send you a copy as well. So mid-rise, load bearing, again, the typical, you want to look at repeatable floor plans. So that's the key, just like with wood, is you got apartments, multifamily, hotels, assisted living. We really want that repeatable floor. So you're loading from the top down. So you want to have those floors, the loads from the upper floors. And then the nice thing about cold form steel, you can have lighter steel members on the upper floors, and then they get bigger as you go down on the lower floors. So you're utilizing the load bearing walls, and then you have different options for the floor systems. C shapes, you got some different composite systems like I-spans composite system with concrete. You have K-series joists, structural decking, precast, wood, and then CLT. And then you want to look at that floor sheathing. You're using the non-combustible floor sheathing, plywood, gyp topping or concrete topping on metal deck. And then the last thing on the balcony, you want to look at how are you going to transfer the loads from the balconies. And not so much on the hotels, but on the apartments, multifamilies, that's of course pretty common, pretty popular still. So a couple of the most common, the one in the middle and the lower middle is probably the most common. Just C joists, common C joists, most common that we run into are 12-inch C joists with a non-combustible floor sheathing, 3/4 inch tongue and groove, great product. And then you can also do, we've had some customers that want plywood, so you can do the same thing as long as you get the fire ratings. You don't necessarily have the non-combustible, but you don't need that for every job. And then you can use a metal deck and concrete or gyp topping. And then up here in the upper left is a composite joist and deck system with concrete. And then even just a structural deck, typically like on a hotel where you got a little bit shorter spans, nice and compact, very cost competitive. Decking has gone up quite a bit in the last couple of months. But even with that, it's pretty efficient system. So all these are pretty efficient. And then when you really leverage, like someone asked, when you get involved, I mean, that's the biggest thing. You get involved in the engineering on the front end. That's the biggest way you can, one, save headache, but also save time. So you get all that done on the front end. You get things engineered. We do individual panel drawings, coordinate everything. And then you're going to get everything you're prefabricating those components as the foundations are getting dug and installed. So that's the biggest benefit. You're getting all that done as the rest of the system's being in place. So if you wait until the last minute, you can't really leverage the benefits as much. Okay, and then maybe we should just cover a couple examples here. I'll kind of breeze through this. Metro apartments, it's a load-bearing job. 7 stories, load-bearing walls, floors. We have a video on our website if you want to take a peek. That video I showed earlier is based on a concept of like this building. 20 weeks, we had it dried in, had 2 blizzards, guys just kept working through it. And just the carrying cost, study said that the owner saved about $200,000 or $250,000 just on carrying costs for saving time on the project. So February 1st, they had 1 floor done. There's a podium on the 2nd level. So again, retail on the 1st floor, podium on the 2nd floor line, and then we went up from there. So you can see end of April, they're just the last floor is getting set. Fiserv Forum. So even on the more complicated projects, there's less opportunity for prefab, but I thought this is a good example. Again, big project down in Milwaukee, down in the Milwaukee area. Our contract is worth $20 million. Our work needed to be done in about 12 months. We did the enclosure and then all the interior framing. We had 170 people on site, 14 foremen, 167 miles of studs. So that's both interior and exterior. Almost $2 million or 2 million square feet of drywall. And there's only so much you can prefabricate. But I want to show is this cornice, this roof section. Even though we didn't prefabricate that in huge sections, we were able to pre-component a lot of these into smaller pieces that can throw them up on the swing stage, and they set those, hand set it, and then they use traditional framing to infill that. And then same thing with the eyebrow here, and then the vertical walls. We prefab that, even scan some of the walls to verify some of the steel so we can make sure our panels fit. But there's only so much we could do on the inside. We would have had more time on the front end for planning. We might have had more opportunities, but we probably would have had a lot less than 170 people on site. Milwaukee Ballet. So this is a job. They had a 40-day enclosure schedule, and we actually enclosed that exterior of that building in only 7 days. It went pretty fast. The general contractor was great to work with. They had pre-planned. They had everything out in front of us, out of our way, and so we were just able to roll. Only had 33-foot high panels. Did the window and temporary enclosures and wood blocking. We didn't do the air and vapor barrier, but you can see again to access those slide clips at the slab, both at the roof line and the second floor line. We left the sheathing off, and it was still pretty efficient. And then so basically, with everything we did, combining other systems, saved about 6 weeks on the schedule total. And another job, pretty compact little building, 24,000 square foot, a 5-story. We just, our panels on this job were actually 54 feet tall. We incorporated, the tube steel, air and vapor barrier. Let's see what else. Wood blocking, went pretty quick. And the whole idea was to get the roofing on and get the interior trades as soon as we could. So that was the big push. And then also, I wanted to bring up, sometimes we don't know. Obviously, you want to have window openings and all that coordinated ahead of time. And that's one of the big things is that we run into is people not, contractors not buying out the window supplier, like especially for punch windows early enough. And then obviously you can modify those afterwards, but it's not the best way to go. On this job, there were a couple of windows they didn't know. And then they went ahead and turned us loose, and we just modified a couple of those, and it was pretty easy to modify those afterwards, but they were good. They didn't hold up the whole operation for prefab for a couple of little windows that we just tweaked afterwards. Lincoln Academy, I'll just breeze through that. Some offsets. It's really this knife plate, pretty critical to get all that coordinated. We did all the brick angles and incorporated all that within the wall panels, including the tube steel in the building. The goal was to cut 7 weeks off their schedule to get the interior trades started earlier. Now, the 11-story office building, again, the reason I throw this in here is a lot of people think that if you have a traditional post-tension concrete and you're going, slab to slab, infill framing, you can still use prefabricated construction on a situation like this. It was a factory applied air and vapor barrier system, but you can see at every floor line at the columns here, hopefully you can see that. Every floor line, we just have to come back afterwards and treat those seams. So if we had bypass, we could go several floors before having to treat that. But again, you can still incorporate prefab construction with bypass or floor-to-floor construction as well. So the key steps to make that happen, field considerations, is the sequencing. You really need to start with the sequencing, whether it's bypass or load bearing. You need to look at how you're going to start. If you're going to start clockwise, counterclockwise, or you're starting from the north to south, whatever that is, plan that out and then stick to the plan. You want to look at the site access. You want to look at the storage, trailer storage and turnaround. Some companies would just drop this trailer off. Well, they back up and you unload the panels and shake it out on site. We don't do that. We just stay away from jobs that require us to drop off a load of panels and you just shake it out on site. It's just very clumsy. You lose all the advantage of prefab, tracking around in mud and everything else. So we plan the trailers and make sure that the trailers are sequenced in the way that they're going to install it. And of course, you want to look at the crane size and reach. Make sure, are you going up and over the building, or are you going to be moving, relocating the crane? Again, first panel built and loaded isn't necessarily the first panel set, so you need to coordinate that. And then you don't want to forget about the safety plan. Who's allowed to work within the zone, and it's very critical. And start looking at prefabricated construction and coordinating the trades and where everybody's working. biggest challenges from my perspective, traditional mentality, and really just, there's so many great superintendents that are innovative and they're making hundreds of decisions every day. But unfortunately, you get into that rhythm, and if the project management team isn't awarding the contracts early enough, then they're forced to do that. They don't have any other way. So, if you can just move some of those decisions earlier and really get out of that and start making those decisions and planning up front, that's the biggest challenge I see. And then a big thing is it's getting better, but coordinating the CAD files between the different disciplines up front early. Hate to state the obvious, keeping a job clean and organized. It's even more important for prefab construction, not to be tripping and over stuff, and fast paced. So be ready and get stuff ready out in front. So these two obviously go hand in hand. It's fast paced, so make sure that all the other trades are ready. I cannot do a presentation without talking about one of my pet peeves, is the professionals getting in the industry without field experience. So whenever we can mentor young professionals getting in the industry, get them out there on the job sites, get them out there appreciating the general contractors, superintendents, foremen, and learning about how these products go together and how you build stuff. And there's so much inexperience with young professionals with power and decision making, but they don't have the experience. Get them out there with their boots on and learn and ask questions and take advantage of the knowledge that's out on site. Okay, we kind of covered this again. Lack of planning and having a manufacturing mentality. Convert the jobs into a more of a manufacturing site. Well, how are you getting in? How are you getting materials in? How are you getting trucks in? How are you getting manpower in? Where are the toilets? You have one on every floor. How are you getting people up and down the steps? Are they climbing ladders? Or do you actually have temporary stairs for the trades? Again, those are the kind of things. Plan and get that stuff done early, as it helps every trade execute. Okay, I just have a couple more slides. 5 key steps. I've boiled this down to the 5 most important steps here. Architects, engineers of record, just design with faster construction in mind. You don't need, even if the job doesn't go prefabrication, I think the job can still benefit from incorporating some of those same details that I covered, incorporate them into the design. And again, even if you don't prefabricate it, I think you can get better construction, faster completion times on your projects. Step 2, decide early and award that scope early. Step 3, just incorporate as much as you can up front into the systems and get out of that siloed mentality that this is what this trade does and this is what the next trade does, and incorporate that as much as you can into one discipline. I don't care if someone comes into our shop and does some of this in our shop out in our parking lot, but incorporate that into the systems to take advantage of the opportunities on speeding up your projects and eliminating that frustration for our customers and getting these buildings built. Again, I find it so frustrating when we look at a job that gets 12-month schedule and you could build that thing in about 4 months. Why aren't we building projects that much faster? And instead we kind of fall back into the standard routine, and this is how buildings are built. So keep pushing that envelope as professionals that we are. And don't forget the gap. Don't forget that the most important thing is starting with a foundation and steel that's properly installed. So keep it flat, square, and plumb. So, and that gets overlooked so often. And the reason that people like wood frame construction and they don't want to deviate from that sometimes is that you can have a lovely looking foundation and it's all over the place, and your wood walls will just conform to the belly and the imperfections in the concrete. And you wonder why you have a 1/2-inch sag in your wall somewhere up on the 3rd floor. There's so many things that can benefit from just good quality construction. So it's no different than prefab on the prefab side, and you got to have square. Our products come out square and plumb. You got to have a foundation steel that match that. So Again, a little bit slower in the front end will save a lot of time on the back end. Okay, and be ready. Plan for the speed and update the schedule. So you just got to make sure the other trades are ready when the project is ready. And if you've got, 4 weeks in the schedule and you think you can get it for done, have a contingency plan for getting it done for one and be ready for it. So I think that's all I have. That is it. So,
Pete, thank you. We've got some more questions in chat.
okay.
Give you a glass of water, rest your voice for a second.
I'm sorry, I tried to cover everything I had without getting it too overwhelming. So hopefully I was able to share that without glossing it over too fast.
And I didn't want to interrupt you, but going back to where you're showing some of the flooring applications, Chris was asking, so after you get the framing up, would you pour the concrete slabs on the floors before the next wall level above when you're doing load bearing walls?
Yeah, that's one of the considerations when you look at I'll just pull that up here maybe. But if you look at that floor system, that's one of the critical things on the early side you need to look at is what is that floor system? You got to make that decision early. If you use concrete, yeah, you really need to set the walls, set the decking or whatever floor structure you have, pour the concrete, set the next walls. So if it's a big enough job, you're going back and forth. Here, I'll just stop sharing. I don't think there's any value to share that Q&A. But with that floor system, if you have a big enough job, you can hopscotch it a little bit and pour the concrete and set the walls. But if you use a form deck, that's the most common that we see, especially in the bigger markets like Chicago. There's a lot of C-joist form deck, which is about a 1/2 inch thick. And then we just keep going. We keep going vertical, and then they pour the gyp topping afterwards, and you still get your fire rating and everything after that, and you don't slow down the job. So anytime you need to slow down for the concrete, it's just one more, you've run into more weather issues and some other things.
So is the prefabricator stamping the drawings? I mean, the engineering part of it?
Usually, yeah. Usually we like taking the design piece. There's a lot of risk if we take someone else's design and we need to fabricate to that design. We like incorporating our design in the system. We feel like we have several tricks that we can incorporate in that to streamline the process, both from a manufacturer, but more importantly, from an install point of view, that most engineers would not do. They would not incorporate some of those.
So, I mean, it's a delegated design and you're the designer for the wall system.
Yeah, normally that's the way it works. Every once in a while the design is done, and we've done jobs where we wish we would have just spent $50,000 and redesigned it because it cost us $100,000 extra to build it the way it was built. So.
Okay.
Do you work with an in-house structural engineer in your staff, or you work with a third party?
We used to have in-house engineer, but there's only so much that person can do without bringing on more engineers. And I think most of you realize how critical it is and how hard it is to find good design professionals. So we find it's better just to team up with engineers that have a huge workforce, and then we can delegate the work within who has work and who doesn't have work. So we try to keep that within a group of about 3 really good engineers that we like to work with. So.
Okay. Paul had asked about for the floor system with the structural concrete panel, if there's UL designs for that. We try to keep our presentations generic, but yes, what's that information? I'd be very willing to help you with that. So
yeah, there's a lot of every system we do, it's got an engineered component to it, or I mean a UL component to it.
And Gerhard was asking about lots of concerns these days about sustainable aspects of steel and concrete versus wood. and carbon footprint and embodied energy. And so you want to make any comments around that, or?
Yeah, again, steel, most of the time it's prefabrication. Cold form in general, it usually comes cut to length. So there's very little waste on site, especially with prefabrication. We get everything cut to length, so there's very little waste. Again, compared to concrete, there's a big, again, you guys see it probably more than I do, but just the dialogue with what happens with concrete and the aggregate industry and how detrimental that is to the environment. And wood is very sustainable, but I find that, in my opinion, again, it's a little bit biased, but cold form steel is pretty sustainable, 100% recycled steel. And it's got good strength to weight ratio as well.
James was asking about just the logistics of transporting panels to the site versus bulk shipments of raw materials and building it on site. Again, from a sustainable aspect, is this going to take more fossil fuels to transport versus if we shipped everything to the site and assembled it there?
You know, either way, your products have to get delivered. Normally, if you're going to stick frame cold form framing on the job, they're transporting it to the distribution yard. The distribution yard unloads it off that truck. They put it on another truck and then deliver it to the job site. So I think there's less trucking involved. It's more concentrated. We've got huge loads. We've got tons of steel coming in our plant, and then it goes out. But I think it's probably less trucking than traditional.
And
I don't have any study that would back that up, but
right.
That's just my feeling.
It wouldn't be the typical thing, but I have seen a few contractors that have a big enough job that have rented space close to the job site and panelized it there. So just to save some of the transportation costs. That wouldn't, again, there's a lot of logistics of having your own plant to have it and all the equipment you need, but you know, that is a possibility too. So Sheldon is saying, much like CAD drawings, which look more perfect than hand drawings, the documents and 3D information convey a sense of perfection. Is there any easy way for those who rely on these documents to verify them?
Sure. The biggest thing I hear in that question is this is construction. We're using construction products. So if you think we're building a car with precision, it's not. No matter what, this is not. It's not. We're not talking precision when we're using construction products, and it's not. The industry's not there. The equipment's not there. The products aren't there. So expectation that there's going to be some variance. Like our biggest thing is concrete and steel being off, not a cold form framed wall.
So I threw the question out there earlier. Anybody want to have the courage to jump in? What was the largest Twin Cities based project built with this method? Anybody have any guesses? Oh, come on.
Not a single guess.
Not a single guess? Really?
US Bank Stadium.
Oh, that's a guess. That's a good answer, yes. Anybody doing any shopping back before COVID near the airport?
Mall of America.
Correct.
Yeah. Wow.
Correct. Yep. The Mall of America was, most of the Mall of America was panelized in a shop. And the biggest worries when that was built was schedule, what Pete's talked about.
Yeah. That was a long time ago.
And how do you keep working when it was like it was early February here? So in a shop, you keep working. I have a question for you, Pete. Do you often do anything where you're putting the windows in and or like a synthetic stucco cladding? Do you make the panel almost finished?
There are fabricators that do EIFS panels. We do not. We do not do that. We're not set up for that. And as far as the windows go, we do have a couple of projects on deck to do windows pre-installed. but I'll tell you in about 4 months how that went. So of course our concern is how can we protect those so they don't get damaged during trucking. But,
Transportation.
Yep.
So Sheldon did follow up and say, it's not a matter of precision. Is the precision accurate? So, and then is asking, why do we continue to stick build? So when prefab makes so much sense.
again, I think the biggest thing in our industry is it seems like there's so many jobs that decisions are made on the fly, and there's so many decisions and so many things that need to happen on the front end. It just doesn't get coordinated and or even aware of the opportunities there. Because again, when people are used to doing it a certain way, it's not construction is inflexible, but we're very risk adverse as an industry, and no one wants to try an experiment on their job in case it might fail. So I think that might be the biggest holdup. But on the quality side, so every shop's different, every factory is different, but we have tension tables. We do a lot of load bearing. You got to make sure your studs seat properly. So we have everything tensioned in place. We're doing diagonals. We're doing all that layout, and so we can use more precision measurements on our factory floor. But then you got to make sure that it gets shipped. So we use sometimes we'll use heavier gauge products to make sure that the studs, the walls don't bow or twist and get out of plumb as they're installing it. So again, it can be challenging to get that. Again, sometimes the hardest thing in the framing world is build a straight wall, and that doesn't come by accident. But you got to have some manufacturers, even when you're stick framing, their studs that get delivered are plus or minus a quarter inch. So can you build precision into a product, into a building, when you've got manufacturers that think plus or minus a quarter inch is acceptable? So you just have to work within the tolerances, and so that's where we don't have that issue in our shop, but we do have peers that have had issues with that because of their manufacturers.
Gerhard is thinking about what I was thinking about. So what's the largest assembly or largest panel you've ever shipped?
54 feet is the largest, and we made those 8 feet wide. We wanted to get it on a truck. So we try to keep everything under 12 feet wide in one direction anyway, so we can get it on the truck.
So how do you label the panels so you get panel 1 goes where panel 1's supposed to go?
It just comes in the pre-planning. You lay everything out ahead of time, and then as it comes off the factory floor, they're labeling it as they go. Again, most of ours, there's not a lot of repeats. There's windows in different locations, so they're one-off. Everything seems like in construction, everything's a prototype anyway. So our panels are most of the time no different than that.
Do you provide the cranes for tipping them up, or how do you coordinate with the general contractor typically on a site, or is that job by job basis?
On a load bearing job, if there's a tower crane on site that they're providing, yeah, we would use that. On a mid-rise construction, most of the time we're providing our own, and we use a lightweight mini self-erector. That's for our purposes. Our system's pretty lightweight, so that's big enough, or heavy, for our loads. But otherwise, we're just using for enclosed building. We're typically just renting that from a local crane company.
More questions?
Pete and Chris, I have a comment about just we talked about the Mall of America. One thing that we experienced on the Mall of America when building that job was the joints between the panels. If the panels were 8 or 10 feet wide, we still had to be concerned with the insulation value and the air vapor drive between at the joints, just like you would be concerned with those same joints on precast concrete wall panels.
Yeah.
So it's not a comment about prefabrication or anything like that. It's just a comment about just a cautionary note about design and detailing of those joints, where you might have either not necessarily a building expansion joint, but a panel joint for carrying brick masonry, or EFIS, or metal wall panels or anything like that. So just a comment, I guess.
Yeah, good point. You know, especially if you can spray foam from the inside or outside, you definitely got to take that into consideration on the quality control side and which direction you're going to get to it from.
Yep, and you don't ever want to bridge over a building expansion joint or control joint either. So you still want to honor that. So
Correct.
we're about 7 minutes after. Any final thoughts? Anybody hungry? It's lunchtime.
Pete, I just want to thank you again for the presentation personally, and for obviously not reading the slides verbatim.
Yes, well, thank you for that tip.
Well, I had a feeling the way that you do your presentations, you weren't going to be doing that anyway. So
Yeah.
it wasn't trying to anticipate what you were saying. We're going to say it was really just something I've noticed from past comments made by my colleagues and others. So, but thank you so much. It was quite educational and just great. It's always good to see the panelized process being utilized the way you're doing it.
Yeah, you're welcome. It's my pleasure. I'm passionate about just building buildings that are just less frustrating for everybody. And it's good to see the technology and the innovation that's happening in construction, and we can start seeing some big changes taking place. And it's good to see a group like you guys that are interested in looking at, because it starts with a good design, incorporating that in with the customers and the general contractors. So it's good to see that you guys are really on board and learning as much as you can from that. So.
Okay, so one last
Chris,
question.
I do have one last question.
Go ahead, Joe.
Where would we find Pete's contact information?
Well, I'll provide that to anybody that needs that.
Yes,
So-
could you email
Got
that?
that,
to me?
everybody? No, not a problem.
Thank you, sir.
Just Pete, from a spec writing standpoint, is there anything major you need to see different in the construction documents if it's panelized versus site built?
Nothing that really comes to mind right off the bat, but when you're specifying products is if we're incorporating that, it's cost always comes into play. So not being too locked into any one product, I think it's good, but it also makes it less flexible for the different manufacturers that are out there with the products. Because obviously we don't want to be dealing with 10 different products on our shelf. So again, you talk about inefficiencies. Now we got different people that are trained. So we like keeping our product to a select base, but we get it that different spec writers are keeping it, keeping it with the product because they're familiar with. So that's always something we run into.
Okay, very good. Pete, thank you again.
Well, good.
We appreciate it. Yes. We'll
Thanks for
share
having me.
information with everyone.
Thank
Again,
you.
register ahead of time for continuing education. Let us know that. Get that to Jordan. And we'll see everybody on the 12th of April.
Thank you for the presentation.
Yep. Have a great day, everyone.
Okay.